Okay, so my name is Arturo Bonrostro, and my topic is Neuralink. I chose this topic because when I first found out about it, the idea of developing a technology like this seemed impossible to me, and that immediately made me more interested in how something like this would even be developed. So here you can see um, that the chip is an implant that goes directly into your skull. And from the chip, there are threads that come out and are directly attached to different parts of the brain. As you can see, some of those parts are the visual cortex, which are used to restore impaired vision, the auditory cortex, which is used to restore impaired hearing, and the motor cortex, which is used to restore motor movements. So the first goal of this technology is to tend to people with spinal cord injuries and help them control their movements as if they were in VR through computers or mobile devices, which I'll get into later. And later goals of the same technology would be helping control other neurological disorders such as Parkinson's. So here, um, I'll just get into a bit of the technology or the major components. Um, so the link is a device that is implanted into your skull and connected to your brain. It's about 8 millimeters in diameter, and this would be implanted by a robot that they're creating since the threads are so fine and this procedure has to be so precise that they're trying to eliminate human error from the procedure in itself. Um, Next is the threads that come out of the link and are attached to certain parts of the brain. Um, so there are about 96 threads and 1,024 electrodes that allow the link to process the fine information such as actions, thoughts, things like that, and process it between your brain and the link. Um, so this will allow for certain sequences to go back and forth. And the third major component is a charger, which is wireless and allows you to charge the link from outside of the skull. And um, this also plays into the fact that the link in itself has Bluetooth and connects to your phone. So they're developing this so that you can connect to other things without having to physically connect it to the link. So here's just more information on the link, and it's Bluetooth compatible, as I said. Um, it will be able to convert signals from your brain to information with the coding that they're creating. And it's built to work with as little components as possible because they want it to be as small as possible, but also be able to process information quickly. So next are the threads, which are shown in the image. Um, as I said before, there are about 1,024 threads directly in this region or the regions of interest, and they have to be directly attached to these regions in order to process such fine information like actions or intended actions. They're made out of thin film metals and polymers so that they can be moved easily, and they have added corrosion resistant adhesion layers and rough electrode materials so that they can handle the wear and tear of being inside of your skull, but at the same time, they won't damage anything. So some of the trials of this technology that they've started was with pigs at first, just to show that it could be implanted. And then the second trial was a little bit more advanced with monkeys. And as you can see in the image, this monkey is playing Pong with its head, which is allowed by the link. And human trials haven't commenced, but their goal is to start them soon. They were supposed to start later this year, but due to COVID, that plan has been pushed back a little bit. So here, I'll explain who will use this technology. The first intended users are people who suffer from major spinal cord injuries, and this is the part of the brain that the threads will be located in order to make this possible. It's the highlighted region, and after that, if that's successful, they will move on to those who have Parkinson's or suffer from seizures. And as I said before, when I explained the major components that the threads will be in, they will also try to treat those who are blind, deaf, and have other neurological diseases. Um, so the plan is to first help those in need, um, and then move on to those who are healthy as well. So their goal in the end is to be able to implant the link into those who are healthy as well, and have this be a form of expression that they can use or communicate with each other without even having to speak. They could share their thoughts, emotions, or intended actions, as I explained before. And they also aim to be able to have the link um, be able to make up code without having to have to physically change the link, and be able to update it with this type of technology. So some ethical issues that this poses, since this is such a, I guess, sophisticated and aggressive form of new technology, there are a lot of problems that could come with it. And some of these problems that have to be addressed are the overall security. Um, so they have to make sure that this technology is secure and doesn't get into the wrong hands or other people who aren't the user, or who the user doesn't want using, since it controls such a large part of them. Some other ethical issues are the power of the artificial intelligence, like being able to process your memories and have them stored. And another ethical issue would be the safety, more importantly, the surgical procedure. As I explained before, they're already addressing the safety in creating a robot that will complete the surgery. And some possible solutions to these issues would be to place limits on artificial intelligence. Elon Musk, the founder of Neuralink, has said himself that it would be a smart idea to limit AI and make sure that it's safe before it gets out of hand. Another solution would be to implement laws um, so that if any of these problems become serious, there are consequences to these actions. And the third possible solution would be to have thorough tests and trials in order to ensure the safety of this device and make sure that people won't be harmed. Here are my references and any questions. Thank you.